Yeah, so as we're going through the presentation, it's kind of broken into sections. So at the beginning of the next session, if there is a question you have, feel free to ask. All right, so let's get going. Hope everyone's having a good day. We're going to talk about Dockerfile best practices. All right, so what is a Dockerfile? So a Dockerfile is basically a bunch of commands that when run together are going to build your final image. So as we look here, here's a really simple Dockerfile, and this is one that you'll find on Docker's website. So we're starting with Ubuntu. We're copying in some files. So this is where we take files from our local file system and we add them to the image. We then run a command. In this case, we're going to run the make command on that directory that we just brought in. And then the CMD option is what's going to happen when we actually run this container. So when we start the container, we're actually going to run Python and we're going to spin this app up. So command is a runtime command. Everything else is going to run at build time when we're building the image. All right, so let's take a look at our first Docker file. So we're taking a simple Spring Boot project, which follows the Maven project structure. The development team has already built it with a combination of Gradle and Docker, and it takes roughly 2 to 2.5 minutes to build. So here you'll see we have our run command. So this is how they're building it. They're doing it with Docker run. They are voluming in their local directory, and then they're executing some Gradle commands against that. So this is building it, compiling their code with Docker run and not with a Docker build like we will be doing for building our actual image. They're also using a Docker ignore file to ignore things like your Git directory, your Docker Gradle directory bins. It's going to help keep that context smaller, which is important because if you have a massive context for your build, you're actually going to slow your build down, even though it's not the actual build that's slowing down. But you have to serialize all these files out over the wire and then get them to the Docker service that's running. So the less that you have in your context, the faster it's going to be to actually start your build. So when we look at what they came up with, this was their first attempt at a Dockerfile. And this is really the runtime only. They're doing the compiling with Docker run. With Docker build, they're actually building our runtime. So here we've got Ubuntu. They're copying in everything from the build context into this /app directory. And then they're running some installs. So they're adding Java, they're adding NetTools and Vim so that they can do some support work, it would look like. And then at runtime, they're going to start the Spring Boot application. And if you're familiar with Docker, you're probably looking at this and going, well, I can already see numerous problems with this, which is great. If you're not familiar with Docker, that's why we're having this conversation. So this is actually based on something that we've seen at clients because this is how they understand the process to work. So when you look at this first Docker file, they're looking at it the same way that people look at a VM. What am I doing? So I'm starting by picking an operating system. I'm copying in all the files that I want. And then as I was going through, what would make my life easier? I need Java, obviously, to run my application. I needed NetTools and Vim because I was having problem connecting this container to other containers, and I wanted to try to troubleshoot what was going on. And then I had Vim because I probably wanted to make some modifications to files at runtime. And when we look at the build stats, initially is on a fresh machine where we haven't run anything before, takes about 3 minutes to build this image. Anytime we change a file, we're looking at about 2.5 minutes to rebuild. The reason it's going to be less is because we had already pulled that parent image, that from Ubuntu. And our image size is roughly 600 megs. So now we're going to actually optimize it. So any questions before we get into optimizing? All right. So let's talk about layer caching. So the best part really of building within Docker is that every line that we have is a layer, and every layer is cached independently. So I should say it's a waterfall, but they are all kind of like save points. So if something were to happen, I can go back to that save point and just pick up and go from there. So when we look at the Dockerfile we have, if you think of all of those as save points, if something changes, I pick up at that line and I go forward. So I really want to utilize the cache as much as possible because I want to have my build be as fast as possible. So having some of these things cached so I don't have to do them again is going to be a huge bonus to me. So when we look at this, obviously changing the file itself, any place that we add a line in, delete a line, that's going to change our build cache and it's going to invalidate it from that line down. Remember, because it's a waterfall flow. If you added a line and removed a line, and then you removed it and you run your build again and you notice it doesn't seem like it did anything, you might already have that previous version cached yet, and it will just reuse that. When we're looking at maximizing our utilization of the cache, make sure you're only copying in what you really need. When you look at your copy commands, that's going to be the biggest spot in your Docker file where you're going to invalidate your cache. So the smaller you have those commands, the less likely it is that you're going to invalidate your cache. It's also going to cut down on the size of your image. The other thing is the order of execution matters. Remember, it's a waterfall flow. So if I change something at the top of the file, I have to then cascade those changes and rerun every line in my Docker file. And the last thing is we want to bundle commands. So if we're concerned about things getting cached independently from each other and they really should be together, we need to bundle those together. And we'll see an example of that. So when we look at this first file, the biggest problem we have is this second line here. So this copy into app. So what's happening is we're taking everything in the build context and we're bringing it over. But what do we really need? So when we look at everything else that we're doing here, we're running apt-get. So we're installing some tools. But the only file that we really seem to be using is the jar file. So if we change this to just copy in the jar file, we will see that our build stats don't really change. So we made this modification. We don't see that big of a change. It still takes roughly 3 minutes to 2.5 minutes. Our image size went down a little bit. But the big thing is now we don't have to rerun all of these apt-gets unless we change the jar file. Prior to this, any change, if we updated the README, if that was part of our build context, anything like that, it would always trigger these installs to be rerun again. Next problem we have is when you look at where we have this copy, it's at the top of the Docker file. The problem with this is when you're looking at this, it means that every time we have a new version of our jar, we have to reinstall Java, which just doesn't seem right, does it? So if we move this to right before it's needed, which is at that very bottom, we'll see that our build stats change dramatically as far as the rebuild. So the initial still takes 3 minutes, but our build time on jar change dropped to 5 seconds about. And the reason is I don't have to reinstall Java. I don't have to reinstall the NetTools or Vim just because I changed my jar file, which is really what we want. So I don't need the jar file until I'm about ready to spin up the Spring Boot application. So we move it there. And you'll see this pattern a lot with copying files in. you bring in the bare minimum you need, you run the commands that you need to utilize what you brought in, and you can have multiple copies if it's going to make sense for your application. All right. Last thing we're going to talk about with caching is when caching goes wrong. So here we see that we've got apt-get update running on its own. So it's in its own layer. It's going to get cached separately. The problem with this is if a new tool comes out that is not part of what we had already cached in apt-get update, we're going to have problems pulling it in. So this is where when you're doing the caching, you want to run things together. So we have two options for this. One is we can add apt-get update to every one of these lines. So we're going to run apt-get update more frequently, but it's going to make sure that we're always pulling in that latest version of what's out there, and we should be able to find the tools that we need. The other option is we combine everything into a single layer. So here we do apt-get update and we do the install, and we install all three tools at the same time. So when people say, well, which is preferred? It comes down to how much do you think this command is going to fail? If you don't have high confidence in this command being able to run successfully, you're going to want to break it up into smaller steps because then they'll be cached independently and you'll be able to kind of go back to that safe point. So if I say, oh, net tools might fail, but I have no problem with JDK or Vim, those installs would work fine. I probably want to break net tools out and put it at as another line in here. The reason is if net tools fails, I have to rerun this whole thing because none of it got cached until it's completely done. The flip side of this is the more layers you have in your image, you do potentially run into a performance issue at runtime with the massive amount of layers. So something that you kind of have to figure out based on your application. But in this case, we're going to leave it as a single line. So any questions on caching? All right, nothing on caching. Let's talk about reducing size. So the next thing we want to do is we want to build the smallest image possible. The reason for that is as you're looking at utilizing tools like an orchestrator, like a Kubernetes, a Docker Swarm, and you're thinking, hey, I might have to fail this over from a machine that this is run on to a machine it hasn't run on. The smaller that image is, the less time I'm going to spend having to download it. So when you look at some of these, and typically we saw this with old.NET files, we have like a 2.5 gig file that you're pulling over the wire versus something like Alpine Linux, which is like 4 megs. It's going to be really simple to pull that Linux one over and get that spun up on numerous machines, whereas I'm potentially going to throttle my network trying to pull that 2.5 gig file over on multiple machines. And it's just going to mean that it potentially leads to a lot longer downtime. So how do we reduce size? Dump any unnecessary files or dependencies. So we don't want to copy in things that we're not going to need. So in this case, we only needed the jar. So don't bring in anything else. That's where we save that whole 1 meg. Use Docker Ignore to help remove any unnecessary files. Again, that really helps with the build context. If you have massive files or directories and you know they're not going to be used in your image, add them to the Docker Ignore, even if you're not bringing them in the copy, because that will make your context smaller, which will make your build start faster. And then remove development dependencies from non-development images. That can also reduce your security risk. This is where we'll see in the example here. You don't want tools that it's like, yes, this really helps me debug the image when I'm running it locally. So when I spin this container up, I love having these tools. You're not going to do that in production because you're typically not going to be running like a Docker exec to get into a container and try to troubleshoot it on the fly. That's just a poor practice that's going to lead to security vulnerabilities. Next thing is clean up after installations. So Remove your zip files after you're done unzipping them. This seems kind of straightforward, but again, this is stuff that you want to run in a single layer. So as I copy in a zip file and I unzip it, I want to make sure that my next step after that, not the next command in the Docker file. So I don't want to put this as a separate command. I want to run it as the same one, because otherwise what happens is I bring in my zip file in one line, I unzip it in another line. So now that's cached. So now I've got the zip file, I've got the zip file and all the extracted contents, and then I go and try to delete the zip file. All that does is it says, hey, going forward, hide the fact that the zip file is here from the rest of the images. It doesn't actually delete it. You have to run all three of those together to actually make sure that that zip file is not going to be in your image going forward. Clean up and install, there should be uninstall temp files, or clean up and install your install or temp files, and then remove any applications you only need it for installation. If I added curl and I used curl to pull a file in, and then I don't need it anymore because I'm not going to be executing curl commands, you're better off deleting curl. All right, so when we look at reducing size, so again, we're picking up where we left off. We've got our build time at 180 seconds for our initial. So first time we run on a new machine, 5 seconds for jar changes, and about 600 megs for our image size. We've got a couple of tools here we don't need. Again, the net tools in Vim are great when I'm debugging and I'm having to go in and run like some Docker exec and go in and try to figure out, hey, why isn't stuff working on my local machine? I'm not going to do that in production though. I should not have Docker exec privileges in production. So anything like this, I actually want done outside of the container itself. I want some other tooling that's going to be monitoring my networking. So let's axe those. That drops a minute off our build time, and it drops almost 100 megs off the image size. Next thing we're going to do is we're only going to install required components. So we're going to add this command as we're installing Java that says, don't install anything just because it's recommended, only give me required components. So only the required pieces I need to install Java. That is going to get me down another 15 seconds, and it's going to drop about another 50 megs off our image size. And the last thing we're going to do is remove any temp files. And you'll see, again, we're running this all in a single command. If I ran these as separate run commands, it's not actually going to change my image size. Because overall in the image, they're still there. They're just going to be hidden. All right, so that isn't going to change my build time at all, but it is going to take another 20 some meg off of my image size. So any questions on reducing size, why it's important, steps to do it? All right, let's move on to parent images. So the biggest thing with parent images, you always have to have a parent. Make sure you trust your parent. I'm not going to open this link up, but from the description of the link, I think you can understand what happened. On Docker Hub, somebody had put out an image. So you can see we're using Ubuntu. Ubuntu means that it is a Docker trusted image. It is a version of Ubuntu. If you pulled like n/Schultz/Ubuntu, that means it's something that I called Ubuntu that I uploaded to Docker Hub. It could be Ubuntu, it could be something else. It could be Ubuntu with some malware that they're not scanning for just yet. If you pull that down because, hey, this looks like it's going to make my life easier and you don't trust it, it can lead to massive problems. In this case, I think the people that had uploaded the images were actually using them to farm Bitcoin. So running a Bitcoin mining farm on other people's hardware. Next thing is don't reinvent the wheel. So we'll see where that comes into play. Make sure that you select a version. So the biggest thing with this is If you don't select a version, you're going to get latest. Latest might work today, but it's not necessarily something that's going to work going forward. And then find the smallest image that does what you need to do. It's going to give you quicker downloads, and typically it's going to give you less risk. All right, so when we look at our parent image here, we have Ubuntu. And we're installing Java to that, but OpenJDK is already a supported image. You can just download OpenJDK on its own. So we'll do that. So now we don't have to install Java. Java is going to be installed. It may not be Ubuntu anymore. I think OpenJDK by default, it runs on Debian. But it saves us that step of having to install Java. Unless we really needed Ubuntu as our OS, and they even might have some flavors of OpenJDK that are out there running on it, we're better off going this route. What does that do to our build? Well, it knocks almost, a bit more than a minute off of our build time, because now I don't have to install Java. I can just pull an image that already has it installed. But you'll see our image size jumped up. They either have additional things that they want on there, or they didn't do as well a job of cleaning up as we did. Next thing we're going to do is we're going to specify a version. If we don't specify a version, we're going to get the latest version of Java that's out there, which I believe is Java 14. We were running on Java 8, so we're going to specify Java 8. What does that do? Again, doesn't really change our build time, but you'll notice our image size went up. So apparently Java 14 is a bit smaller than Java 8. But we're pulling in a full JDK. We don't need a full JDK to run a Java app. We only need the runtime. We also aren't specifying what version of Linux we want to use. We don't need a massive version of Linux. We can get away with Alpine. So we're going to change our version. We're going to stay on version 8, but we're only going to get the JRE version of it, and we're going to use Alpine Linux. So we're going to switch to that tag. That drops our build time to 25 seconds initially, 5 seconds for a jar change, and then it drops our image size down to 116 meg. So this is about the smallest that we can get this application to be without trying to reinvent the wheel and go even beyond that. So any questions on your parent images? All right. Next, we're going to look at security. So from a security standpoint, you want to run as the least privileged user. You want to use trusted minimal images as a base. So we already did that. We switched to Linux, or to Alpine Linux, to make sure that we're running that smallest image. You want to patch your images for security fixes. You don't patch containers. When you're looking at running this in, let's say, Kubernetes, and I've got an image, and we find some security flaw with this OpenJDK 8 JRE. We go, oh, I need to patch that. I need to pull in either a new version of it, or I need to add this patch to it right before I build the image or add my code to it. You're going to do that in the image itself. So that's a Dockerfile patch. You don't do this at runtime. You're not going to Docker exec into all of the containers and try to patch them on the fly. Containers are like cattle. So if there's an issue with it, let it go, bring in a new one that doesn't have that issue. So when you're patching, patch your image, not your container. Don't put secure information in your Dockerfiles or environment variables. If it's in your Dockerfile, it is going to be there forever. People can basically look at the history of your Dockerfile commands and see things that you don't necessarily want them to see. If you're putting things in environment variables, so I'm passing in a password that I'm going to use at runtime, or I'm setting up an environment variable that has something that I need at runtime, not only is that there in the Docker container, so anyone who wants to look at my environment variables can see that. But if my container crashes, one of the things it does is it dumps out all my environment variables to the command line. So it's just going to be there in plain text form for people to read. The last thing is add security checks to your pipeline. Image scanning is a great way to start. So this is basically running a tool against your build and making sure that you've got, you don't really have malware or any other known defects in there. The next thing is image signing, and this is where you digitally sign your images, and this can help prevent things that you don't trust from making it into your production environment. So when we look at security, the big thing to start with is that this is running as root. The problem with running as root is if someone were to find an exploit, which they found in, I think, 2018 in Docker, where they were able to escape the container and get to the host system and they're running as root, they're going to be able to wreak all kinds of havoc. So in this case, what we want to do is we want to create a new user that's not going to exist on our host machine, and we want to run as that user. And this user is not going to have sudo access to change to root or anything like that. This is a good way to make sure that you're running as someone that even if somebody got into your container and tried to escape, they're not going to be able to do anything. All right, so then let's move on to compiling the code. So good news is we've got a great image for runtime. We don't have any additional dependencies. It builds fast and it's a small size. The bad news is we don't have an image for doing compiling of our code. So building the jar is external to the image. We're just copying that jar file in, which means we can't utilize the Docker cache. So every time we run that build command doesn't have built-in caching to it. So the problem with that is it always is going to run that full build, which was taking, I think, 2 to 2.5 minutes. That's going to run every time that we do this. So if you're looking at it from a CI perspective, I build that jar, that 2 minutes always happens, even if our image doesn't necessarily need it, even if we didn't make a code change. So how do we add in our compiling of the jar to our runtime? First thing we're going to do is we're going to start by getting a new image. So our base image here is going to switch from OpenJDK 8 to Gradle. And again, it's got to be a full JDK because we need to actually compile the code. You'll notice that we got rid of the user group for security. That's because this image already runs as Gradle. So it's not running as root. Next thing is we have to add a working directory. So we're going to copy that, add that up there. This is basically going to be where all of our commands run from after this point. So this is basically like we cd to this directory and everything below this is going to run out of that directory. This is helpful when we need to know what directory we're in. We're going to copy in the code. So we're going to get rid of copying in the jar file because we're going to build the jar file. So here we're going to do the copy as 2 steps. We're going to copy in the build Gradle file first and then the source next. The reason why this is broken into 2 steps, if there are actions I want to take on the Gradle file itself, and you see this more with like package.json when you're dealing with Node, I can add all of my dependencies and cache them before I do anything with actually trying to like transcompile my code. The benefit of that is it's cached, and unless I change my package.json, I don't have to do anything with those dependencies. So source code changes that don't impact my dependencies can help me, can prevent me from having to rerun that step, which is going to save me a lot of build time. In this case, we're not doing anything with it, but we're going to leave it in as a second step. Last is we're going to run the build. So right before the command then, we're going to do this Gradle build. We're also going to change the directory. So now this is going to be a relative path from this work directory, the build libs, and that's where our jar is going to be. So when we actually run this, we find out it doesn't work. Gradle throws a permission issue. And the reason it throws a permission issue is because work directory in here got created as root. So we're going to work around that We're going to make the directory on our own, then set it as the work directory. And we're also going to do a chown on the files as we're copying them over to make sure that Gradle owns them. So when we do this, we see our build time jumps up to now 105 seconds for initial and 75 seconds for code change. And our image size jumped up over 100 megs. But the benefit to doing this is now if I'm not changing my code, I don't have to rebuild the image. So before we were always having to rebuild the jar file, and that was taking about 2 minutes on its own. Now at least we have it cached. And if we're not changing the code, we don't change that jar file, which means our image is going to stay the same. So then the question becomes, how do we add build steps without increasing the size of the runtime? And the solution to that is multi-stage builds, which have been around in Docker for a few years now. When we're looking at this, you typically have 2 stages in there, which is what we're going to have. You have your build and your runtimes. That's the most common way to go about this. You can have more than 2 stages. Some examples of when you would do that are when you're pulling in artifacts from different images, which we'll see an example of, and when you're building different versions of your image. So I need a multiple versions of Linux, or I need a production version and a dev version because I want my dev tools to be enabled. So those are reasons where you might have more than 2 stages in a single file. So when we look at a multi-stage build, we're going to start by taking the 2 image files that we had and we're just going to combine them into a single file. So this top one here is the one that we just did. So this is compiling the code and then running it. And the bottom one here is the one that we liked before this. This is our super small, just runtime only version of the code. So the things that we have to do to marry these 2 up is we have to first remove anything from our build that's not actually needed for building. In this case, it's a single line. I don't need to actually run a command to spin up my Spring Boot application on here because I'm not going to run my Spring Boot application from my build image. The next thing is we have to pull files from the proper location. So if you look here, we're looking at going back to our local file system and pulling in that jar. That jar is probably not going to be there anymore because I'm not going to necessarily run a build separate from this. I actually want to pull the jar file from this image up top. So we do that by specifying that this first image, we're going to give it a tag of builder. Then in the copy, we're going to say from builder, so from this image above, I want to copy in this jar file. So this is that working directory that we specified, plus that relative path on it where it was in build libs, and we're going to copy that over here. So now we have a single Docker file with 2 stages in it. When we look at what this does to our build, you will see that our build time jumped up a bit. As far as the initial time goes, it jumped up 15 seconds. That's because if you've never run this before, you've now got to pull in 2 parent files, one for build, one for runtime. Our code changes still take about 75 seconds, and our image size drops back to that 116 megs. This top image up here is basically throwaway. Unless I go and tag this and actually want to do something with it, it's going to exist on my system for cache purposes, but it's not actually going to be part of my final image going forward. All that is in my final image is from this second from statement down. The nice thing about this is no code change, no rebuild. All right, so then when we look at other multi-stage builds, here's an example of some other options. So here we have 3 stages. We have a front-end build, which is Node. We have a back-end build, which is .NET. And then we have a .NET runtime where we marry the 2 of them together. one of the things to note with Docker build is these are going to run in the order that they show up here, and they are going to be run one at a time. So the front end build has to complete before the back end build gets kicked off, and then the runtime runs after that. The thing to note with this is just because I changed the front end doesn't mean that the back end build is going to rerun. It's all going to be cached here. So from here to here, anything that changes in here would trigger a back end build. But the front end build changing doesn't necessarily mean that the back end build is changing. The back end build code has to change for that to get kicked off. But it is worth noting that the back end build will not start till the front end build finishes. Here's another version of this. This is a multi-stage build where we have the build one that we just looked at. We have our production version of this, and then we have our dev version of this where they're adding back NetTools and Vim. Now, it might look weird to have prod above dev, but the reason we have that is, again, because it goes through every layer in Docker build, it would always build dev even if we're not going to use it. So what we want to do here is we want to run this -- target prod, which is going to stop it at prod here, and it's not going to run dev. Otherwise, the last image that's in here is going to be the one that finally gets tagged by default. Here we're saying stop at prod, this is the one we want to tag, and this is going to prevent dev from even running as far as Docker build goes. So any questions on that? Otherwise, we'll jump into buildkit. All right, so that's Docker build. Buildkit is not enabled by default, but it is a better version of Docker build. You can enable it via an environment variable per build by setting this Docker build kit equals 1 before you kick off your build. Otherwise, you can do it across all of your builds by setting it globally, either in your daemon.json or your Docker desktop settings. And that's where you just enable buildkit to be true. Big thing is better performance. So there's, I think, like a 10% performance gain in performance just by enabling buildkit, but we get concurrent builds, we get smarter build routing. We also get some new syntax for security, networking, and mounting. So when we look at buildkit enabled for this, so once I have buildkit enabled, so by default it was sequential, so front-end builds and back-end builds. With buildkit enabled, these are going to run in parallel, and then runtime is going to run after them. So what you're going to see is that now I'm going to get faster builds because it's going to look at this and say, hey, these two, there's no link between front end and back end, so I can just kick these off at the same time, and then runtime is going to wait until they're done, and then it's going to pick up and go. Now, this is more like promise chaining, so what's going to happen is runtime will actually start on its own, and it'll end up blocking on that first copy line, that back end build. So it will hold there waiting for back end to finish, then it'll hold on the next line waiting for front end to finish. But it will make our builds faster by being able to run these concurrently. The next thing is, by default, all stages we're building. So when we're looking at this where we have build, dev, and prod, here if we do this with build, Docker build by default, builder's gonna run, then dev, then prod. What's gonna happen here is when we switch to buildkit, it's gonna look and say, hey, you only wanna build prod? That needs builder, but it doesn't need dev. So it's just gonna skip dev for us, which means now the ordering of the stages in here isn't as important to how we optimize our builds. So this will get skipped for us because buildkit is smart enough to know that it's not needed for prod. Prod has no dependencies on dev. All right. Then when we look at the syntaxes, so like I said, there's security, there's network. The really cool stuff comes with the mounts. So there's one is the bind, which lets you bind directories instead of copying them over. They still have to be in your build context, but it will let you do things where you can basically like volume in your code instead of copying it in to the image. So there's some performance gain there. The next one is, of all of them, is my favorite, is the cache. So this lets you cache directories for your compilers and packages, and we'll take a look at an example of that. You also have the ability to mount a temporary file system. You can use secrets. So if there are things where, hey, I need something, but I don't want this to be in my image, you can use a secret now to actually pass that in. And the last is SSH. So if I need to SSH into something, Git, for example, I have that option. So when we look at secret, the first thing you have to do is you have to add this experimental flag to the top of your file. But here you'll see in our run command, we have this mount type secret. We're going to stick the target into this directory here, and the ID is secret script, which is going to tie back to the secret ID that we use in our build command. And then our source for that is this my script file. So what happens is this is going to let me run this command using this my script sh, but it's never going to actually be part of my image. So going forward, typically we'd have to copy in my script, run this, and then delete this as kind of 3 separate commands. Or you either have to pull that my secret from somewhere else, because if you do a copy, it's already kind of stuck in that single command. But this lets you use it without actually saving it to your image. The next one that's important here, though, is the cache. So again, we add this experimental flag. You'll see here in the run, we've added this mount type cache, and we said the target is going to be our home Gradle-Gradle. So what this says is it's going to take all of our dependencies and it's going to cache them off for later. So if my dependencies aren't changing, I can just keep reusing that cache. And it's basically the same thing as having my caches, my dependencies copied into my jar file for me. So what this does for our build stats is, and actually this should say 120 seconds to start, but our build time for code changes drops about 25 seconds because our dependencies are going to be cached going forward. So the first time we have to go and install everything with Gradle, but that second time we don't. And any times going forward. So any questions on anything that we covered as far as Dockerfile best practices?
And feel free to unmute yourself or use the Whova chat to ask a question.
Hi. You had mentioned not putting passwords and things like that into environment variables. Where would those go?
So those you're going to want to use secrets. The orchestrator that you use, whether it's Kubernetes or Docker Swarm or some of the other ones that are out there, they all typically have a secret. What that's going to do is it's going to let you set something that's going to be encrypted on the machines. So Docker Swarm, for example, it's going to let you basically create something that exists on your host machine that's encrypted, and then it's going to decrypt it and it's going to stick it in as a file at runtime that your application can access, but it won't be in the environment variable. And if you're not aware of what orchestrator it's running as, you don't necessarily know where to go for that secret. But that's typically how you want to do that, is you want to use secrets because it's going to be more secure. And that's going to be a runtime concern based on the orchestrator you're using.
Thanks.
Yep. If you need that same stuff for compile time, so with your images, switch to buildkit and use that secret flag to bring that stuff in so it doesn't end up being part of your image going forward.